Hello, now we are going to look at fractional indices. So a fraction just means what it always has meant, like 2/3 here is a fraction, and indice is our other word for powers of numbers, so squared numbers or cubed numbers or so on. So it is the little number that sits up in the top right hand corner of our bigger number, our base numbers. So this 5 to the indice 7 or 5 to the power of 7 means 5 multiplied by itself 7 times. What we're going to look at today is where we have fractions up here and what it means to have a fraction up here. So instead of having a whole number like 7, we might have 7/3. And what does that mean to have fractions in powers or indices? So we start off here and we have the square root of 9. This is how we're going to start thinking about fractional indices. So this is the square root. There's an implied 2 here that we don't tend to bother writing. And what this is asking us is, what number would we multiply by itself 2 times in order to end up with the number 9? What number would we multiply by itself twice to end up with the number 9? And we know that the answer is going to be 3. The square root of 9 is 3. But we can look at why that would be the case. So we know that the square root means what number would we multiply by itself twice in order to end up with 9? Well, we can write 9 as 3 squared. So what number would you multiply by itself twice to end up with 3 squared? Well, logically that has to be 3, because this means 3 by 3. So what number would you multiply by itself to end up with 3 by 3? It's just 3. This is why this argument works. But we can write this in terms of the power notation that we know. So this is 3 to the power of 1, this is 3 to the power of 1. So if we had the square root of 9, and we know that's the same thing as the square root of 3 squared, and we know we end up with 3 to the power of 1, well, could we represent the square root as a power that would make this step more reasonable in terms of what we know about our indices rules? Well, what we could say is the square root is kind of like the opposite. It gets rid of this 2 here and leaves us with 1. So what would we end up doing if we were taking powers of things? We have 3 to the 2. What power would we put on that to end up with 1? And it turns out that we're taking a power of a half. 2 times a half would be 1. So a square root is the same as the power of a half. Because if we take this here, rewrite this. If we multiply our powers like we know from our power rules already, we'd have 2 times a half, which is 2/2, which is 1. So we end up with 3 to the power of 1, which we know logically must be the answer. So again, the square root means the same thing as power of a half. And it turns out that this extends itself. So this is just x to the power of a 7th. What number would you multiply by itself 7 times in order to end up with x? Well, that's going to end up being the same as putting a little 7 here in our square root. So what number would you multiply by itself 7 times to end up with x? So our square root ends up being the same as power of a half, or the other way around, power of a 7th would be the same as the 7th root. What would you have to multiply by itself 7 times to end up with our number inside the 7th root? So what would we have to do here if we have a little 3 inside of our root symbol? That means what number would we multiply by itself 3 times in order to end up with 27? Well, I know that I can write 27 as 3 cubed. So this isn't the square root this time, because I have a little 3 here that tells me it's the cube root. It's how many times what number would I multiply by itself 3 times in order to end up with 27? Well, if 27 is 3 cubed, that means that must be 3 again. Now let's write this question. This is 3 to the power of 1. Let's write this question in terms of powers. So our cube root of 27. You need to rewrite this. That 3 needs to sit inside the tick to make it very obvious that it is not 3 multiplied by the square root of 27. It's the cube root of 27. So when writing this, be careful your tick part at the beginning needs to be big enough that you put your number in here actually inside this overall symbol, as opposed to having 3 square root 27, which means 3 times the square root of 27, which is a totally different question. So you can see how similar these look if we're not careful with the way we write. So just be careful of that as you are going on with our more complicated square roots or cube roots and so on. Let's write this as a power like we did for our square root was power of a half. Well, the cube root is going to be 27 to the power of 1/3. Same reason as we had x to the 7th is the same root as the 7th root of x. So this is 27 to the power of 1/3. Now again, I can write 27 as 3 cubed. And I end up with multiplying my powers. This is the power on the bracket. So I end up with 3 to the power of 3 over 3, which is 3 to the power of 1. Same answer as we got before. So we can see that even though this is a little bit longer to write for now, it's very important for more complicated questions. So we can see the cube root notation, and writing that cube root as a power of a third results in the same answer, and we can see where that is coming from in terms of our rules of indices. So let's do another one here. We have 8 to the power of 2 all over 3. So the way that we're going to deal with this is using effectively this step here in reverse. What I'm going to say is that's the same as 8 to the power of a third squared. If I multiplied these two together, as I would because I have a power on the bracket, I'd end up back at 2/3. 2 multiplied by a third is 2/3. So this is the same as this. Well, 8 to the power of a third is the same as the cube root of 8, which is 2. What number would I multiply by itself 3 times to end up with 8? That'd be 2. 2 by 2 by 2 is 8. So I can rewrite that as the cube root of 8 to be squared. So I end up with cube root of 8 is 2. You can always double check these things on your calculator, but make sure as you're doing them that you are showing step by step how you're changing things. If you put this in the calculator and get out the answer 4, in an exam we would get 0 marks, because what's being tested is, do you understand the rules of indices? Do you understand how to go step by step through this process? Again, writing this and then writing this gets you 0 marks in the exam. So there is no point in doing it. We need to practice the steps in our thinking for how we get from here to here. So let's have a look at what we've got here. 121 to the power of -1/2. Well, I know the power of a half means the square root. That's what we were looking at before. And a negative power means we change the line that our number is on. So this is going to be the same as 1 all over 121 to the power of 1/2. The brackets here don't have any real significance, but you'll sometimes see them in brackets and sometimes see them not in brackets. So everything in this bracket is the power of 1/2, which means the same as the square root. And the square root of 121 is 11. Let's do another example. Also 32 to the power of 2/5. Deal with the fraction part of the power first. So we're going to have 32 to the power of 1/5 squared. Very similar to what we did here. It's generally a good idea to put the fractional part inside your bracket. It is not necessary, but it is often easier to think about. So what is 32 to the power of a fifth? Well, you can rewrite that as the 5th root of 32. What number would you multiply by itself 5 times to end up with 32? It turns out the answer is 2. And again, you can check that on your calculator. But you must show this step by step as you're going through. So 2 squared is 4. And some more examples. We have 3/5 to the power of -2. So we know from our work in indices that we end up with the power simply acting on both of these numbers regardless of the power. So we have 3 to the -2 all over 5 to the -2. Don't really need that bracket there. And I know the negative power means I change the line that my numbers are on. So I end up with 3 to the minus 2 is the same as putting 3 squared underneath the line. And 5 to the minus 2 would be the same as bringing up my 5 to have 5 squared on top of the line. So if I have a negative power, it changes the line that I am on. And we have seen why this works out the way that it does. So 5 squared is 25, 3 squared is 9. Now I have 16 over 25 to the power of negative 1/2. So we're building a little bit on what we did here. So this ends up being 16 to the power of minus 1/2 over 25 to the power of minus 1/2. Be very careful you keep writing this as a smaller number up in the top corner, particularly when you get into fractions. It's easy to write this as something that looks a little bit like 25 minus 1/2. So make sure it's up, obviously above the 25. I could do a better job of that. So let's rewrite that. So 25 is the base number to the power of minus 1/2. Now I'm going to deal with my negative powers next. So this 16, if it moved underneath the line, would be 16 to the power of 1/2. And 25 moving up on top would be 25 to the power of positive 1/2. So we're having to use lots of our different rules, lots of our different methods throughout. Square root and power of 1/2 mean the same thing. So this is the same as square root of 25 all over the square root of 16. Again, you don't tend to write the little 2 here, but if you wish to, you can, because it is the square root. It's just because we use square root so often, we tend to be lazy and not write in the 2. But it is always implied there. So square root of 25 is 5, square root of 16 is 4, and that's as far as we go. We can also, in fact, quite commonly be asked to do something like this, which is to simplify all of these such that you can write it as 2 to the power of something. So we know that we want to write all of these as powers of 2 and use our indices rule to simplify it to the point where we end up with a single 2 to the power of something. And the thing we don't know is our x. So we have 4 to the power of minus 1. So I'm going to move that down to the bottom line, so it becomes 4 to the power of plus 1. And I can start rewriting everything as powers of 2 as well. So I end up with So I'm moving my 4 down so it ends up as 4 to the 1 underneath the line. I have 16 to the power of 3 over 2. Well, I know I want to start writing things as powers of 2. So what is 16 as a power of 2? It's going to be 2 to the power of 4. Again, you can check that on your calculator. And on the top line, I have the cube root, which I know is the same as power of a third. So I'm going to have a power of a third. It's a cube root, and 8 is 2 cubed. Again, you can individually check these on your calculator. And now I just need to turn the 4 into a power of 2 as well, and I can start multiplying these powers on my bracket. So I have 2 to the power of 3 times a third, 2 to the power of 3 times 1/3, because I have a power on the bracket. 4 is 2 squared, or 2 to the power of 2, times 2 to the power of 4 on 3 over 2. And when I start doing my multiply out and simplifying, I get to this step, and then I have 2 to the power of 1 all over. Well, I have same base numbers here, so I can add the powers, multiplying the bases. Same bases means I can add the powers, so I end up with 2 to the 1 all over 2 to the 2 plus 6 is 2 to the 8. And now I'm dividing the same base number, so I subtract my powers. 2 to the 1 minus 8, I end up with 2 to the minus 7. So the x I was asked for is minus 7. And if we get a question like this, as always in maths, you can see it's very complicated looking, but each individual step is just like the simpler questions we did earlier on. So it's very important to keep your head and do one little bit at a time. And that is what we need for now.